Good morning, students. Today we are going to discuss this chapter, Human Eye and the Colorful World. So, monochromatic ray. Mono means one, chromatic means color. If a ray of single color is passed, it is known as monochromatic ray. Next is polychromatic. Poly means many. If the rays are passed which consist of different colors, more than one color, it is known as polychromatic ray. Means more than one color. More than one color. Now white light. Okay, white light is an example of polychromatic ray. White light consists of 7 colors. This mnemonic already you have studied in your junior classes, that is very pure. Violet, indigo, blue, green, yellow, orange, red. These colors combine together to give white light. And under monochromatic ray, if we are passing any ray of single wavelength, suppose that if we are passing red ray, so it becomes monochromatic. Now, here we are going to discuss first if we are passing a monochromatic ray through a prism. Suppose that here one obstruction is there. From this slit a monochromatic ray is passed. Suppose that if we are passing a red ray, so what happens? Here when it strikes here, prism acts as here the phenomena of refraction takes place. So rarer to denser, from air to glass prism. So rarer to denser towards the normal. So if we will draw the normal here, it will move, it will bend towards the normal. You can see here this angle is more than this angle. Now from denser to rarer, if we will draw the normal, denser to rarer, it bends away from normal. You can compare these two angles, you will come to know that this angle is more than this angle. So if this is angle of incidence, this is angle of refraction, here this is angle of refraction, so we can name this as R2, and this is the angle of emergence. Here, if we will extend the incident ray and we will extend the emergent ray, we will come to know by what angle this ray gets shifted from its path. So this is the angle by which the incident ray gets shifted from its path, and this is nothing but this is known as angle of deviation. So angle of deviation is the angle by which the incident ray gets deviated from its path because of the phenomena of refraction when it passes through a prism. So this angle is known as angle of deviation. It is represented by the Greek alphabet del. We write here angle of deviation. This happened because it was a monochromatic ray. That is, we have taken the ray of red color. Same situation is there, same prism is there, and we will pass a polychromatic ray. Suppose that if we are passing white light, so you know white light is the combination of these 7 colors. So what will happen if we will draw the normal here? So here when white light strikes, it splits into 7 constituent colors. here we are getting violet, here it's red. Now when it passes from, and we are keeping one screen here, these rays, rarer to denser, if we will draw the normal here, and here also we will draw the normal, it bends away from normal. So this is violet, this is red. In between we are getting all the other colors that I am not showing. That is violet, indigo, blue, green, yellow, orange, red. So from here you should understand that red has maximum wavelength. Violet has minimum wavelength. So in this sequence, red has maximum wavelength, violet has minimum wavelength. So here, if you can see from top, it is in descending order, and from bottom it is in ascending order. That means red has maximum wavelength, violet has minimum wavelength. So here, phenomena of refraction took place. Here what happens, because white light consists of more than one color, that is it is polychromatic ray, so what happens, it gets split into 7 constituent colors. The phenomena of splitting up of white light into 7 colors is known as dispersion. Dispersion of light. And the band of 7 colors formed, it is known as spectrum. So till here, hope so you have understood. Now next topic that you need to understand is scattering. Suppose that from any ventilator or somewhere you can see the rays of light enter to your room. In that ray you can see many dancing particles, many dust particles you can see. At night when you are just when you are there in a bike or any vehicle, you can see with the help of the headlight of the vehicle that many dust particles you can see in the atmosphere. So what happens? The dust particles, the atmosphere consists of different gases. These gases, what do? They absorb sun's rays and they re-emit. So they are known as scatterers. And they carry on the process of scattering. What is scattering? Scattering means absorbing sun rays and just re-emitting in different directions. So intensity of scattering is inversely proportional to wavelength to the power 4. So from here you know that red has maximum wavelength. So we can say that since red has maximum wavelength, so intensity of scattering will be least. So which color scatters minimum? So you can say red color, red scatters minimum. So wavelength of violet is minimum. So violet color will scatter maximum because intensity of scattering is inversely proportional to wavelength. So violet color scatters maximum. Hope so you have understood the concept. Thank you.